Let's look at DMZ interfaces in this section. So we know that during installation, we're given the option to provision an optional interface, which led us to advise you that you can provision optional interfaces 1 through N. So let's talk about DMZ or optional interfaces. So as we can derive or deduce, optional interfaces allow us to further segment traffic. That's the whole idea, to split traffic off accordingly, subsequently creating abstractions, additional layers, which allow us to basically segment traffic and secure services accordingly. So wherever possible, it's usually ideal from a security perspective to segment your network traffic, web servers from middleware, from databases, from other core services, etc. And within pFsense, those interfaces are registered as optional interfaces. So registered or reflected as optional interfaces. So we need to create a DMZ. So our primary internal LAN is 192.168.1. Perhaps our DMZ interfaces can wear subnets such as .2, 3, etc. through .n. So let's see what's happening. We should be able to provision this rather straightforwardly. So let's set up DMZ interface, and the tasks will include, of course, provisioning a new NIC. So provision NIC in new VLAN, and it's all virtualized, so everything should be segregated by VLANs, or if physically connected to switches, also separated by VLANs. So provision NIC in new VLAN, and provision host in new DMZ VLAN optional network, ensure connectivity, etc. So let's see how this pans out. So we now need a new NIC, and we have a new network. Let's take a look at our virtual infrastructure manager. That's VMware. So for the firewall, pFsense or UCBT pFsense 1 or UCBT pFsense 1, when we take a look at the resources that are currently allocated, we see that it has one NIC or two NICs, one on the WAN network, one on the internal network. So one internal NIC, that is. We need to provision a new network. Now we've already set up a new network called DMZ. If we take a look here in the configuration of the server in networking, we'll see this additional NIC that's been added to handle the DMZ area. So in networking, we've got VM network 2, which is the 192.168.1.0/24 network, the base VM network, which is 192.168.75, a management network, which also shares the same subnet with its specific IP. And now this newly created DMZ net with a VLAN ID of 3, which is independent of the other groups. So traffic will be segmented or segregated at the VLAN level from the infrastructure manager's point of view, which is ESXi. So that means when we assign this new NIC on DMZ1, the traffic should not be segmented or should not overlap. They should be segmented unless there's a bug in the infrastructure manager in VMware, that is. So from UCBT pFsense 1, we want to edit the settings and add a new NIC. It's going to be network adapter number 3. Everything's based, of course, on the E1000 driver, which is compatible with BSD, Linux, etc. So DMZ1, connected power on, and that's a new interface. That's simple. Now, whether or not the operating system detects it on the fly remains to be seen. Sometimes you'll have to reboot in order for the interface to be picked up. So that's DMZ1. Well, of course, we'll need another NIC another NIC associated with another node or modifications to another node. So, for example, Unix CBT BSD2. Let's drop its 121 address. This will be reconfigured as a dhcp node. And we can just use this node, just ensuring that it's not using too many resources. So it has 3 NICs. We can drop some of these NICs. Perhaps we get rid of this one, and perhaps we reallocate this one to the DMZ subnet, so it's a part of the same VLAN. And then this one can be fired up momentarily. But before doing so, we'll make sure the optional DMZ is set up from the firewall perspective. So this is using 1024 megs. That's fine. And from the perspective of the overall server, that should be more than manageable. Let's take a look at the summary. and we're about 8.3 gigs, so we've got enough space. So UCBT BSD2 will be brought up momentarily. It'll come up with a static IP address that belongs to the base network, which will shift to DHCP once the server is configured. Now, from the perspective of pFSense, it should not have detected this interface already. That can be confirmed by double-checking the interface. Let's take a look back here, refreshing the interface, and let's see what interfaces it sees. So it sees no new additional interfaces, just the EM0s and 1. And for that, we should reboot the instance to have it pick up this new interface. If you can't afford the reboot, then put it on a secondary that's part of a cluster, and then have failover take care of matters for us automatically. So let's go ahead and reboot. And all along, we haven't been saving our changes. We'll look at that perhaps in a miscellaneous section as we wrap up the initial intro into pFSense. Certainly, we can back up the configuration in the event that it crashes, bombs, or is misconfigured for some reason. So this should come back up momentarily. We can send some packets to see just when that happens. Maybe 30 packets to 75.4 or 3. At some point it should come back up, and then we'll be able to reconnect, and the ICMP rule should come back up once it comes back up. And we can also check the console of that node itself, UCBT pFSense 1 console, to get a sense when that interface comes up. And of course, that interface will not have an IP assigned to it automatically. It'll be set to DHCP. There are no DHCP servers in that newly allocated DMZ VLANs, so it'll remain unconfigured. There's the EM2 interface, and its state is set to up. That's that new interface. So EM2 is what we'll associate momentarily. So this looks like it's coming back up. Let's pop over to the other side. 30 packets have expired, but it's now back up. So we should be able to refresh, and let's just take a look. And this is why it kicks us back to the beginning, so that we don't inadvertently execute a command such as reboot, which may not be intended. So now these are the configured interfaces, but a new interface exists. So we'll take a look at interfaces. We've got LAN, WAN, EM0s 1 through 2. We'll need to add an interface, and this will become an optional interface, opt1, which is assigned to this particular EM2. We'll click on save, and then in terms of its configuration, opt1 now becomes a new interface. We'll enable it, and it needs to have an IPv4 configuration. We said we'll use addresses 2 through N up, so 192.168.2.0, etc. IPv6, it can be set to any of the protocols that will allow automatic configuration, such as SL, AAC, etc. It'll just auto-configure the interface. MAC address will just use a default. IPv4 address, we'll have to describe that momentarily. Speed and duplex, it should default to gigabit, but let's give it an IP address of 192.168.2.1/32 because it's just its IP. There is no upstream gateway. The default is on the gateway interface, and you can add a new one. So if the interface is an internet connection, well, it's downstream. Select an existing gateway from the list or add a new one using the link above, so we'll see. And the local, since this is a local LAN, the upstream gateway should be set to none. So in other words, once traffic's routed through this interface and makes it onto the WAN interface has an upstream gateway, so that's not needed. And this is the block private networks RFC 1918 that we don't want because we're using private networks. Block bogon networks, which includes loopback, that's fine. We can block that. And let's click on save. This will adjust the settings. So opt1 configuration has been altered. And it says don't forget to adjust DHCP server range if needed. After applying to the DHCP server will need to be configured to handle addresses on the 2 subnet as well. Otherwise, it won't dish out addresses on that subnet. So now we've got this new interface. In the interfaces list, we should see opt1. This is a configuration screen for it. But what about DHCP? DHCP is not set to give out addresses on opt1. It needs to be configured accordingly. So note 2.2 through whatever the range, available range, 2.0, 2.1 is the subnet, so we need to modify this, enable DHCP on the interface. So we want the range to be 192.168, let's say 2.1, or 2. Let's say 10 through maybe 192.168.2.100 or something along those lines, something that makes sense for the environment. And then in terms of the pool, if you need additional pools outside of the range, you can specify them here. Gateway uses 2.1, which is itself The domain we know is the default that's obtained, which is Linux CBT.internal, but we can always respecify per subnet just to be clean. Domain search list is the same value. Release time, well, it's going to be per subnet base, although you can have a global setting. But if you want this to be clean as well, just take in the value that we used earlier, if it makes sense, a week or 2 weeks. So as we've mentioned, 7 times 24, let's just make sure we pop that in. 24, that'll give us a full week times 168 hours times 3600 gives us a week. And let's just make sure we've got that clear. 168 times 3600. There's our value. So that's going to be for 1 week and then double that for 2. So let's multiply that out by 2. Copy that value in. And no failover pairs defined just yet. No static ARPs. And insofar as the DNS server, which is 75101, that can be configured as well. Dynamic DNS, as we've done before, it's going to be Linux CBT.internal. And we want to enable registration as we did before. And that should be good. Now let's double check. We always run into this problem seemingly. Specified range lies outside the current subnet. So the current subnet, let's just double check that this is 2.192.168.2.1. We need to double check that this should be 2.0 as a subnet. Let's see if we can fix this. So let's go back for a moment. This is dhcp server config opt1. It seemingly, maybe we specified the address incorrectly. So 2.1 is the IP4 address. No upstream gateway, that looks good. And let's just make sure there's nothing else that needs to be specified in here. Static IPv4 configuration, MTU, that looks good. MSS. So let's see what it's complaining about. Let's go back to DHCP. Opt1. And it's supposed to be enabled. And this is reading at 2.1, whereas for the LAN, let's see what it's got, 1.0. So it's reading it incorrectly. It should be 2.0. And this has 2.2 through 2.0. This is an incorrect range. It's actually incorrect. The configuration is clobbered. Let's see if we can do 192.168.2.2 through 192.168.2.100. It's reading the range incorrectly. That's the problem. So that's why it's a form field issue. It took it in incorrectly. So let's see how we can work around this. We could try removing the interface altogether and redefining it. So let's take a look at our interfaces. So opt2 is em2. Let's clobber that interface. And we'll wait for this to come back, and then we'll reassign it. So the interface has been deleted. That means in services, DHCP server, we should no longer see opt1. And in interfaces, let's try to redefine the interface. Opt1 on em2, that looks good. Let's save the changes. Let's modify opt1. And it's going to be enabled. IPv4, static IPv4, not DHCP. For now, let's omit the IPv6. Something in the form fields threw us off before, and that was the reason why it didn't work. So the IP address configuration, 192.168.2.1/32. And we should double check this against the other configurations. Let's just pop this into another tab here. And maybe we can get LAN into another window. Just double check how it's specified. So this is actually specified as /24. That's the problem. This is a form field interpretation issue. That's why it was written incorrectly. So that's why it relegated it to just that address. So let's go to 24. That's just a small nuisance. That can be worked around. So you just incorrectly specify /24. This is the way you tell it the range of the network. And we'll block bogon nets, click on save, and now it should have the range applied. So now when we go to, in fact, we can now turn on SLAAC, which will configure IPv6 automatically as well. Let's apply the changes. Let's turn on SLAAC. We just wanted to rule it out before, because sometimes when you're using these interfaces, they cause trouble in terms of the interpretation of the field results. So let's click on apply. And now let's go back to DHCP server and try to manipulate opt1. So now we see the full range. That's more like it. So enable DHCP on there. It's going to be the full range, wins, DNS, gateway, domain name that we put in earlier. It's going to be Linux CBT.internal. Let's put that into the buffer, pop that over for the search list. And the lease time, well, this is for 1 week. And this we had to do, or for 2 weeks. This is what we had to do earlier because of the bug. Divide that by 2, get the original value, 604800, 1 week. No failover pairs, no static ARPs just yet. Dynamic DNS should be set to Linux CBT. Internal is a zone. Doesn't matter what IP subnet they're coming from, it should register. And the range, begin, range, end, 192.168.2.10, 192.168.2.100. That should cover the nodes. Let's try it again. Save. And now finally it should write the configuration. It's taking a bit longer, so it should be good. So now we have the 2 DMZs set up correctly. And so long as we bring the other node up, it should be able to get an IP in that range after we've, of course, manipulated the configuration. So let's go back here, navigate to Unix CBT BSD2, power it up, take a look at its console, where we should see that it tries to come up with a static address. And with the static address, it'll wear the address. It just won't be able to communicate with other nodes within the same layer 2 broadcast domain because the IP will be incorrect, including the default gateway itself, 2.1. However, from default gateway, if you run a TCP dump, you'll see the node sending out broadcast packets from time to time. So you'll see attempts to communicate from it. And there we should see some settings. Let's see what it's doing. Default gateway 75.1. So it's already configured itself to a hardwired IPv4. And of course, it's going to try to communicate with various protocols such as NTP and fail. And this will just take a little bit to time out and then continue allowing us to boot. So you can see here it's set to use 75.121. That certainly won't work, as well as 221. So we were trying perhaps Apache and other things using different addresses, virtual addresses. Those won't work on this new DMZ1 subnet. So quick recap of the steps. You need to either physically or virtually connect your firewall to a new DMZ, add an interface, and that connects it to the new DMZ. Configure the interface. It usually shows up as opt1, the first DMZ interface. Configure the interface, set up dhcp on that interface, optionally connect it to DNS, and then bring your node up. So it's showing the host is down. That's correct. It should not be able to communicate outbound. Now let's try to log in and see what we can do here. So the interface is configured on BSD via rcconf. We'll modify rcconf and we'll set interface EM0. Let's comment out EM1 and just work with EM0. So no aliases are necessary. And this line we can just block and just make it DHCP. So replacing all of this, which simply DHCP will do the trick, and its hostname should be registerable in the default domain that we've specified. So this should be good when it comes back up. Let's do a reboot quickly here and see that it gets an address from the new DMZ that's created. And then, of course, with this new DMZ, you have to write rules in order for the DMZ nodes to communicate with other nodes on the base subnet of 192.168.1.0, which is protected by the firewall, or outbound for that matter, to nodes on the 75 network, as well as out onto the internet. And also routes will have to be provisioned to indicate that there's a new subnet, 192.168.2.0, hiding behind the pFsense firewall, as we did with 192.168.1.0. Otherwise, communications will fail there as well. I'll see what this is doing as it boots up. So it's setting its host name. It'll do some DHCP gathering. And momentarily we'll see if it gets an address. Should be there. 2.1, so it's gotten an address, or offer from 2.1, that is. 2.10 is the address, you can see here. So 2.1 offered 2.10. So that's the address. And now it's going to try to communicate with the NTP that's provisioned, which should be 75.101, 75.102. So that's going to be based on whether or not there are outbound NAT rules which allow the node to communicate outbound. So if it takes a while, that's probably the case that it's not configured. So let's take a look at the DHCP leases. We should see this new node pop up. That's going to be Unix CBT BSD2. It was issued a nice long lease, and it's an address of 2.10. However, from a firewall perspective, natting, outbound natting, what is configured? Is it allowed to go outbound, automatic outbound? So here's 192.168.1, and this is automatic configuration. Well, actually, these were manual configurations that we placed in for 22 and 80. The automatic NAT rule, if a node from the inside tries to communicate outbound, pFSense should try and write that rule. However, let's see where it is. Let's see if it's actually doing so. So we'll go back. Actually, we can try from the server with diagnostics to ping. On the local subnet, it should work. So 192.168.2.10. This should work because it's on the same subnet. It knows how to find 2.10. That's fine. Now, let's go back to the node and see if we can communicate outbound via the automatic rule. So let's see, the setting date via NTP, can't find host, FreeBSD. Well, of course, that we expect. If it's trying to access the net, it'll fail because the edge gateway has no way of getting back to this internal network of 192.168.2.0. So we'll have to set a route there in order for it to come back. And actually, we have a separate window on the side here. We're going to go ahead and pop over and set that route. So let's see what we can do here. We've added the route on the side, and for security reasons, we just have it in a separate window so we don't reveal potentially vital information for connecting to our networks. And I'll see what's happening here. This is still trying to bring its services back up, but now our edge router knows how to get back to this 192.168.2 subnet. So let's try to log in and see what happens. So let's do a netstat.rn and we'll cat etc resolve conf momentarily. So from this, we can see the default gateway, the way out of here is through 2.1, and we know we can communicate with it. Let's see what we've got for DNS. Resolve conf 2.1, which is the DNS mask instance. So let's send some packets to 2.1 to be sure it responds. And there's a filtration. It's not coming back just yet. Let's do an if config. We should have 2.10, and that's correct. Let's do a dig www.linuxcbt.com. And no dig, so host www.linuxcbt.com. And it's not communicating with it on 2.1. So no traffic's going through it just yet. We're able to ping it, but it's not coming through. So let's see what's happening on this other side. We'll pop back over. So the NAT configuration looks okay. Let's take a look at the firewall configuration. The rules are probably not set as they were with the LAN interface. So let's see what's happening here. For LAN, we've got a rule anywhere, and actually LAN net to anywhere for IPv4 and IPv6. So we need similar rules on the opt interface. Let's see what's happening here. All we have is a block for bogon nets. That's the problem. It's not allowing any traffic in. So we want to pass on the interface opt1 IPv4 any protocol heading outbound. So the source anywhere, destination anywhere coming in on the LAN interface. We can even log these packets and I'll just give it a generic pop IPv4. And then if we copy this and make it IPv6, that'll cover that protocol in the event that it's used at some point. Let's click on save. So that gives two rules which allows traffic outbound, which are similar to what we found on the LAN interface. IPv4, 6 coming off the LAN net. In this case, it's coming off the opnet. You can actually specify the opnet to ensure that it matches. So that's going to be in the source section. So coming off of opt1 net, it just makes it a little more discreet. And on this one as well, let's modify it. It would work otherwise, but certainly we just want to make sure that we narrow it into the DMZ, just so the DMZ is a little more secure. So this allows traffic coming in off of the opt1 net. The NAT's already there. As we've mentioned, with automatic NATing on the outbound side, the traffic that's coming in will automatically work. That's not a problem when you're using automatic. It'll automatically NAT it, but if a firewall rule doesn't permit the traffic, then it won't flow through. Go back over and try to send some packets to 2.1. That should be from our console. So we'll just find that in our history. Now 2.1 is responding because of the IPv4 rule that we placed in. And there's a resolution. We have no dig, but we have hosts. So now DNS is working. But we certainly still can't communicate naturally with nodes that are on 192.168.75, such as 101, without the assistance of a route back into the 192.168.2 network from the other side. So from this side, it was NATed going out. But if you're on the other side, 192.168.75, and you try to send packets into 2, that'll obviously fail. So this is being NATed out as 75.3, which is the WAN address. We can confirm that. Let's telnet to 192.168.75.101.22. And then on that node, let's confirm the socket. So we'll pop back over, find an SSH instance, and to build one. Neither of these are there, so we'll SSH here. 75.101. And we'll just do a netstat quickly. And we should see the connection coming in. So here we see that the connection's coming in 75.3 into 22, coming off the 2 subnet. But from this net, if we try to say ping 192.168.2.10, then what we see here, let's see what it's coming back with. It's saying it's responding, and it must be picking up a route coming off of, let's do a netstat RN. It must be picking it up off of the default gateway. So let's do netstat RN. Let's see what our current routing table tells us. So it's sending the traffic to the default gateway, and the default gateway must be telling it where to find the 2 subnet. Let's do a telnet 192.168.2.10.22, and that should fail because there's no mapping for it. So the ping came back. It could be that the router's just responding the 75.3 pFSense because it knows it owns the network, but there's no way for it to map back into that DMZ without an appropriate NAT translation. So for example, on the WAN interface, let's say we try to forward a port. You can designate another port, let's say 2223, that points into 2.10.22. But let's go ahead and copy this and see if we can get that going. So WAN interface protocol 192.168.75 source network, and the destination is going to be, instead of 1.2.103, it's going to be 2.10 on its SSH port, and redirect to SSH, but we're going to say this is going to be 2223, so it doesn't conflict with the existing one. So it's going to be 2223. That takes us into that subnet. And this is going to be SSH into Unix CBT BSD2, which is on the DMZ subnet. So quite a bit is required to get it going, but nonetheless. So here is a rule that should allow traffic off of 75.0 into the 75.4 address, ultimately onto 2.10. So long as you use the 75.4 address, which is accessible on the same broadcast domain, that's not a problem. So 192.168.75.4.22.23, that's not a problem. That'll connect to the right node. And of course, all of the other ones should be preserved as well, such as 22.22 to Unix CBT BSD1, and similarly, just plain old 22, which connects to the Ubuntu instance. So that's all going to work. But if you try to say communicate directly to 2.10.22 without the appropriate mapping, which this now has because of the firewall rule, you won't be able to get in. We get in because of the firewall rule to 22, but not to 22.22. Let's drop this, and that looks good. And let's see what's happening here. So the rule allows us to pass through, the route allows us to pass through, the firewall rule allows us to pass through. So this rule allows traffic through, mapping accordingly. And then on the firewall side, let's take a look at rules, see what we've got going on here. In terms of accessing 2.10, well, the NAT created an entry for us. This was automatically built for us, and that's why we're able to get to the node. So a number of things are happening here. Our default gateway gave the route to 2.10. So note, default gateway, which is 192.168.75.1, provided 192.168.75.101 with a route to 192.168.2.10. However, a NAT translation and firewall rule, which the NAT translation creates for us, which we already know. So, and firewall rule, let's say auto created by NAT, is required to access resources on the node. So splitting the address 75.4, we have to break the ports out as we've done in the NAT section. They can't use the same port. So 2222 goes to this node, 2223 goes to this node, and plain old 22 goes to that node. But so long as there's a rule, as we just saw, which NAT creates, which provides access to 2.10 and a route, then you can communicate with the node directly on port 22. So that gives us a new interface with which to work with. Now begs the question, what if we provision yet another interface, another VLAN, another DMZ with another node on it? Well, the setup will be similar. You just have to make sure that you have yet another network defined. So for VMware management, just take a look at your configuration in your networking section. And you want to add a new network altogether that supports that additional DMZ. So for us, that we could call that, say, DMZ number 2, and so on and so forth. So you can add networking to the mix. It's virtual machine, and it's going to be created based on the original adapter, so on and so forth. Or you can do properties of the existing setup and just add a DMZ here, virtual machine, VM network 3, whatever it's want to be called. And let's say we call this DMZ 2. That gives us a new DMZ. The VLAN ID, make it something unique of that range to 4095, 0 to 4095. And that gives us a whole new DMZ, which is segregated. So long as there are no bugs in VMware, that shouldn't be a problem. So now if we collapse all of these, we should see there's a new DMZ. So DMZ2 is a new DMZ. So if we add a new NIC to any of the nodes, let's say pFsense, so to this, we take a look at the settings, edit the virtual machine settings, and provision yet another NIC to DMZ2. That should work. So let's add a NIC, and typically that will require a reboot. So Ethernet adapter, and this is going to be on DMZ2. So now this is ready for a new DMZ, and this we can reboot. Let's go to the console. Actually, we haven't used the console in quite a bit because we've been using the GUI. Actually, there's really no reason why you need to use the console, as the GUI handles pretty much everything. Tell it to reboot. This will come back up. And insofar as the nodes that are connected to the new DMZ, you just have to provision physical or other virtual nodes that are connected. And then you can set up dhcp and repeat what we've already done. So as a quick recap, while this boots up, let's just mention what we've done. So we set up a new DMZ, which we just showed you how to do in VMware ESXi. We provisioned a new NIC associated with that new VLAN, which is DMZ1 initially, DMZ2 subsequently. Then we set up a host in that VLAN, or in that new DMZ. And by ensuring connectivity, we essentially ensured that the optional interface, that new interface, opt1, is configured with appropriate IP services for v4, possibly v6. Actually, it's not back up yet, for that particular subnet. And once the dhcp is running on that interface, then it's just a matter of reconfiguring the interfaces on the nodes that are within that DMZ to either use static or dhcp settings, and then confirm the dhcp settings. Now, in terms of communications, nodes that are outside of the network have to have a route into the network. Outbound NATing is automatically configured, but the firewall rules for the outbound side are not automatically configured. So that's why we had to add those rules that we did. So that's something that has to be done manually. It's done automatically when you set matters up. So take a look at your interfaces. You can add an interface, and this will be opt2, which will be EM3. Save the changes, and then you can manipulate opt2 if you enable it with its IP configuration. So IPv4, Slack, and any settings that are necessary. So say 192.168.3.1 is its address /24. Let's not make this GUI mistake again. So whatever bits you need for your subnet, that looks good. Block bogon nets, not private nets. Save the changes. So now this interface is ready to go, opt2. There are no nodes in it, and you can configure DHCP accordingly. So there's opt2, services DHCP server, there's opt2, and now opt2 is ready to be configured for DHCP server. So that tells you can configure as many interfaces as your system will support and route traffic in between them. And just to recap, ensure that for the new interface you have appropriate rules. Notice that no rules are written except for blocking bogon nets. You have to ensure that traffic is able to flow through it. these are loose rules. These are certainly not secure rules. It's allowing anything from the DMZ or from the subnet to enter the firewall and subsequently exit it through the NAT of 75.3. You can, of course, fine-tune these to match what should come back. So if it's a web server, maybe only requests on port 80.443 should be allowed out, etc. But at least we have basic communications going.